Hello everyone. So in this module we are going to learn from where we left off. So we were learning about cos pi by 2 and all of this, right? Or basically all of this. Okay, 1 second. Yeah, basically all of this, right? Cos 0 equals to 1. Why is it? Because here we just saw this yesterday how this happens, right? P by b. That is base by hypotenuse. Base and hypotenuse both are 1. So cos pi by 2 will also be 1. Hence, so it's p by p. It's p by h and b by h. So b base is also 1. So we saw this in yesterday's video, right? So from this we can understand. So what the textbook is trying to say in further is, so this is a small exercise from yesterday's this thing, right? Take a few minutes and try to solve this. Try to solve the other four. What you'll see is for each of the axes, right? OA, OB, OC, and OD. The lines, the measurement will always be 1. Thus, it'll always be 0, 1, 0, 1, 0, 1 over here. Cos 3 by 2 will be 0. Cos 3 pi by 2 will be 0. Sin 3 pi by 2 will be 1. The value will be 1 only. The value will be 1 or 0. It can be minus 1 also. Sorry, the number can be minus 1, but the value will be always 1. So the value of minus 1 is 1, right? So basically the value will be 1, but then the number could be minus 1. So now if we take one complete revolution, now let's see what the textbook is trying to say in further this thing. And there's a small exercise that you have to do. It's very easy only from what I've explained in the last module, in the last part of the last module. So now if we take one complete revolution from point P. What is the point P? It's here, right? We take this point. So if we take complete revolution from point P, we are taking complete revolution like this till again point P. What we get is, we again come back to the same point P. Thus we also observe that if x increases or decreases by any integral multiple of 2 pi, the values of sine and cosine functions do not change. What is this? What are we talking about? If the value of x increases or decreases. What is p? P is x, right? Till point P, it's angle x. Till angle x, OP is the secondary of angle x, right? So what do we do when we take a complete revolution like this? P to P. Like this, when we take a complete revolution. What is a complete revolution? 360 degrees. What is 360 degrees? 2 pi radians, right? We are in 11th standard now. We use radians. We don't use degrees like bachas. My brother is right here. I'm like making fun of him, but he's too busy doing something on his phone. Lol. So we increase the value of x, of angle x, by 2 pi. So that is 2 pi, right? So that is 2 pi. X plus 2 pi. The value of sine and cosine functions do not change. What is sine and cosine functions? It is this. sorry, it is, oh my god, I got it, is this cos x equals to a and sin x equals to b. And what is a and b? What are a and b? We don't know yet, right? But then we do know that cos x square plus sin x square is 1, right? So sin x and cos x are functions. But then how do we know that it does not change? We didn't get any proof, right? We want evidence. We will not trust the textbook like this. Where is the evidence? Let's see that. Thus, sine 2n by pi plus x equals to sin x. N belongs to an integer. I'll be explaining this part again on a drawing board. Please stay tuned. So this is a quick going through version of it. If you understand from this, well and good. If you don't worry about it. You can watch the part. You can watch the next part, and there'll be more deeper explanation on this, right? Yeah. So why is it 2 and pi? So it's we will learn about this in the next module. Some things we'll leave it for the next module, right? So it's 2n plus 2n pi plus x. If you have a doubt, please log off this video, watch the next part, and then come back. Yeah. Plus x equals to sin x. N is an integral number, and cos 2n pi plus x. So cos x, so cos so sine 2 pi, let's imagine this, 360 degrees into the number of rotations. Let's say the number of rotations is 3. So 3 into 360 degrees plus x, and the sine of that, right? Sine of that number. Let's say 360 degrees into 3 plus x equals to y. So sine y will be equal to sine x. But how? We don't know yet. Let's find out, right? Similarly, let's say n is a number. N is an integral number. Let's say it's minus 3 this time, right? So 360 degrees. So that is why it'll be so that is what we are talking about. It'll be 2 pi. Okay, for easy understanding, I said 360 degrees into 3. But then it is 2 pi into 3 plus x is y. We are just assuming stuff. In maths, there's a lot of assumptions. So yeah, we will talk about this. We'll write properly and understand this. So I'll show, right. I'll show it like this. Better. So let's say 2 pi 2 pi plus 2 pi and then 2 pi is what? What is 2 pi? 2 pi is one complete revolution, one complete gola, one complete gola, right? Let's say we have a circle like this. So we are going like this, full circle we are going. So this is 2 pi. 2 pi. So we've got 2 pi here. So what are we doing with this? With 2 pi, we So let's say it takes three revolutions, three golas, right? Three golas it takes from this point. Three golas, one, two, and three, right? So we will. What we'll do is two. What we'll do? Wait, it's not in focus. 3 into 2 pi. What is 3 into 2 pi? Forget it. Nobody cares what is 3 into 2 pi, okay? 3 into 2 pi, 3 into 2 pi plus x. What is x? What is x? As you saw, it's on. Oh shit. What is x? It's on point P, right? It's on point P like this. So this is x. This is point P. So yes, basically that is x, that is P. So we have it like that, right? So this is x. So from here it took three revolutions. One, two, like this. In the third one, three. Right? So that is three. That is 3 into 2 pi. Three revolutions, right? One, two, three. 1, 2, 3. Plus x. Plus this angle x. This x. Right? This is basically our angle. Right? So this is our angle. So sine, and then let's call it y, right? Sine y. So sine y will be equal to sine x, and cos y will be equal to cos sine, sorry, cos x. Oh wait, it will be sine x only, and cos y will be equal to cos x. Yes, sine y equal to sine x, cos y equals to cos x. Why is that? Let's find out, right? So that is basically our idea behind this. So it is what we showed in that video was the idea, right? So cos 2 pi, uh, so cos y is equals to cos x, right? How? Let's find out, right? Actually, till now, people would have, by, seeing the graphical method, you would have understood why this happens. And I think by this explanation, you don't have to, we don't need a second part. You must have understood why this happens, many people. But we'll read more, we'll try to understand more, and we'll, only when it is completely clear, we'll move on to the next part. Yeah. So thus, further sine x is equal to 0, right? If x is equal to 0, sorry, further, what we understand is sine x is equal to 0. If x equals to 0, plus or minus pi, plus or minus 2 pi, plus or minus 3 pi, dot 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 till infinity, right? That is any integral multiple of pi, including 0, right? Any integral multiple of pi. 1 plus or minus pi, plus or minus 1 pi, plus or minus 2 pi, plus or minus 3 pi, plus or minus 4 pi, right? Similarly, cos x is equal to 0 if x is equal to plus or minus pi by 2 plus or minus 3 pi by 2 plus or minus 5 pi by 2. That is any integral multiple, any integral odd multiple of pi by 2. Any integral odd multiple of pi by 2. That is excluding 0. Right? Excluding 0. Any integral odd multiple of pi by 2 excluding 0, or any odd number. Any odd number, right? Multiple of pi by 2 including plus and minus. That is it. That is it, what we are learning, right? So sine, it's written down here also, sine x here. Yeah, sine x is equal to 0 implies x equals to n pi. So sine x is equal to 0 where x is n pi and n is any integer of the world. It could be minus 77777 till infinity, or it could be plus 666. 666 is the devil's number. Ha ha ha. Lol, yeah. It could be 666, it could be the devil's number, or it could be the God's number, or 111. But wait, God's number is 1111, right? God's number is 1111. It could be 1111, or it could be 666, the devil's number. It will always result in being sin x equals to 0, right? Where x could be could be could be the value of 666 into pi, or it could be the value of 1111 into pi. Similarly, cos x equals to 0 where x is equal to is equals to not is equal to. Ayo, I'm an idiot. I'm saying is equal to from that time. Yeah, I've gotten a very bad habit to not say is equals to, because I have a breathing problem. So yeah, I just say whatever is easy on my lungs. Lol. So cos x is equals to 0 where x is equals to 2n plus 1 into pi by 2. 2n plus 1, and where n is any integer, right? So this is how we represent it, right? So n could be 0, n could be minus 1, n could be minus 2, n could be minus 3, n could be plus 1, plus 2, plus 3. Regardless, it could be any integer in the world. Similarly, for the first case also, here also, it could be any integer of the world. 666, devil's number, 1111, God's number. It will always be 2n plus 1. If x is in the form of 2n plus 1 pi by 2, cos x will always be 0. Why? We'll see this, diagrammatically. Don't worry, babies. Right? Don't worry, babies. We have more to see, more to come here. Full is there. Lol. Yeah? Slowly we'll see. Now we define other trigonometric functions in terms of sine and cosine functions. So if we have sine and cosine, aram se we can take out cosec, sec, tan x, right? Cosec, cosec x we can take out, sec x we can take out, right? Tan x we can take out, cot x we can take out, aram se, right? How do we do that? This is a homework. If you've done, if you know 10th ka maths, you can do this. This is homework. So we have shown that for all So we'll read for going further, right? We have shown that for all real for all real number x, sine square x plus cos square x equals to 1. We just saw that, right? Right? Because it doesn't matter if, if it's 2, if it's 3, if it's 4, it'll always be sine square x, right? So from that, again, we take out 1 plus tan square x. We take this out, right? How do we take this out? This is again in homework. And if you don't understand this, not an homework, it's a homework. Shit! My English is, yeah, yeah, it's degrading every day. Low. Degrading. Degrading. It's rotting. Yeah. Rotting, but in another word. Degrading. So yeah, it's 1 plus tan x square equals to sec square x. How will that be possible? So sine square x, we'll show this in a bit. So from that we can take the table out too, right? Pi by x, right? How do we, take this table out, take this table out? I'm like, yeah, translating it directly from Hindi. निकाल सकते हैं इससे बाहर निकाल सकते हैं, I guess. Lol. We can deduce this table, right? So if but I hope you've done your homework. So you must have noticed one thing, right? If sine x is 0, if sine x equals to x equals n pi, sorry, if x equals to n pi, then sine x will be 0. So if sine x will be 0, then cos x will be 1 by 0, will be, and that will be infinity, right? But we don't do that here, right? We don't do that here. So what do? We define x as not equal to n pi, which is not an integer, right? Not an integral multiple of pi. Similarly, same case for cos, right? For cos also we do the same thing. 2n plus 1 in brackets pi by 2. We don't take 2n plus 1, we don't take an integral odd number, an integral odd number multiple which is not 0 as the multiple of pi by 2, right? We don't take x's value as this. Similarly, for everything, we don't take x's value as this, or else cot x, tan x, sec x, cosec x will be 0 or infinity or non defined, right? Infinity is basically not defined, right? It will not be defined because anything divided by 0 is not defined, right? Right? It's a very, very tricky part. That is why I told you to do that little exercise to try to, put this in, right? If you've done the exercise, you'll understand this. Yeah, yeah. I hope you've done it. So, first we will try to understand why if x equals to 0, then sorry, if sine x equals to 0, then x equals to n pi. Why is that true? And why is cos x equals to 0 when x equals to 2n plus 1 into pi by 2? So here we will learn why it is pi by 2, why sine x is equal to 0 is equals to 0 when x equals to x equals to 0 plus or minus pi plus or minus 2 pi plus or minus 3 pi dot 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 dot, dot, dot. Yeah, we learn this in this video. I want you to see this and learn. So how much is pi? Pi is 180 degrees, right? Pi radian is 180 degrees. We know this from past video. So that'll be this much. This will be our rotation. This is 1 pi, right? This is 1 pi. And then from here, we'll again take it like this. This is 2 pi. And then again from here, we'll take it like this. This is 3 pi. And this is 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Every half a circle, half circle, half circle means 1 pi, full circle means 2 pi. And when we go this side, let's take a different color. Let's take green, okay? India has color, okay? Let's say we are starting from here, right? This is minus 1 pi. This is minus 1 pi, right? This is, and we go again like that. This is minus 2 pi, minus 2 pi, and we go again like this. This is minus 3 pi, and then we go again like this. This is minus 4 pi. So like that, we've gotten this, right? We've gotten minus 1 pi, minus 2 pi, minus 3 pi, minus 4 pi, minus 5 pi. So this is minus, so what we get is, what we are trying to do with this exercise. What is it? What's the deepest thing we are trying to do? So this is 2 pi, 3 pi, this is 3 pi also. This is minus 3 pi also. This is 0 dot 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 1 pi minus 2 pi dot 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 dot. This is minus 1 pi. Sorry, this is plus 1 pi and plus 2 pi dot 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 dot. Yeah, like that. And so this is also the same. This point is also the same. From the same logic, this will be 0. This will be 0. This will be 1 pi, 2 pi, 3 pi dot 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 dot, and minus 1 pi, minus 2 pi, minus 3 pi dot 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 dot, right? So that's the logic. We'll create a proper graph for this in some time, and we'll be uploading this in the description of this video. Yes, we'll create a proper graph so that you can see that and refer to it all the time, because in the textbook there is no proper graph for this. So if x is pi or 2 pi or 0, what's the great deal about it, right? How does it matter? So if x is pi over here also, if it's pi, if x is pi, then it'll be over here, right? It'll be over here. If x is pi, even if it's minus 1 pi or minus 2 pi, or any number after that, or any number after this, or any number before this, or even over here if it's 2 pi, if it's 0, if it's 1 pi, if it's minus 2 pi, or anything after this, or anything before this, right? It doesn't matter. This one, this one, right? How is this? Why is it 0? Because the p, what is sine, what is sine? Sine is p by b, which is, what is p? Sorry, sine is p by h. P by h, right? So what is p by h? P over here. If it's over here, p is also 1, and hypotenuse is also 1. It's just a straight line, so obviously p and h will be 1 only, right? Only b will be 0. Sorry, p, what is p? P is 0. There is no perpendicular, there is only base, right? So p is 0. And h, what is h? Hypotenuse is 1. Hypotenuse and base are the same, right? So here we'll get 1. 0 by 1, which is 0. So in all of these cases, it'll be 0. So similarly, I want you to find out for this as a homework. In the next module, we'll learn about this, right? So, so like that, we have understood this part. And similarly, for the next part, for the homework, I want you to find out how will we get all of these values, 1 by 2, 2, 3 by 2, after doing this, after solving for cos x, right? Making the same graph. I'll show the same graph again. I want you to find that first and then this, right? So find this here. And knowing that pi by 2 is 90, knowing this value, you will find y cos y cos 2 uh 2n plus 1 into pi by 2, sorry, okay, y cos x, when this is the value of x, cos x equals to 0, right? So please take a screenshot of this page. Take a screenshot and take a screenshot of this page too. Sine 0 y, y is this, you'll have to make these columns, sine, cos, tan, these three, rows, sorry, in all of these columns, all of these 8 columns, and fill in the table. Yeah, in the next video we'll in the next module we will look into why this is, right? We'll have a proper digital setup. Today was very offline, I can say. So yeah, I can say that. So yeah, no, we'll have a proper digital setup with drawings, with all of these things. Yeah.